Welcome back to my tutorial. In this tutorial, we are going to solve transient thermal analysis. So we are going to solve a boiling egg, and an ordinary egg can be approximated as 5 centimeter dia sphere. The same egg we are going to model it by approximating into 5 centimeter dia sphere. The egg is initially at a uniform temperature of 5 degrees Celsius. Now the initial temperature of the egg is 5 degrees Celsius and is dropped into a boiling water at 95 degrees Celsius, taking the convection heat transfer coefficient to be 1200 watt per meter square degree Celsius. Determine how long it will take for the center of the egg to reach 70 degrees Celsius. So theoretically, it takes around 14.4 minutes to reach 70 degrees Celsius. Now we will solve the same case in code aster. So how much value we are getting? Now just go to salome. Salome is the wonderful solver for finite element analysis. It has pre-processing as well as code aster solver. Now it has got opened. Just go to geometry model to create our geometry. Just go to the case. This is actually a 5 centimeter diameter. That means dia is 5 centimeter. The same case we are going to model it in meter. Actually we are going to solve by everything in meter. Same unit consistency we are going to use. So diameter is 5 centimeter means the diameter is we need to divide by 100. So 0.05 meter dia. Okay. So if it is a radius, so we'll divide this value 0.05 by 2. That's it. Now just directly we can generate a sphere. So this one is the sphere. It has the radius value. So we need to specify the radius instead of diameter, because here they have in our case they have given diameter. We need to specify the radius. So the radius value is 0.025. Just apply and close. So this is the sphere. Now we can check the dimension also. So minus 0.025 to plus 0.025. By adding this value, we will get diameter of 0.05. Okay. So now we have created this sphere. Only single geometry. We need to specify the external convection value. So for that, the external surface is the convection or heating. Anything we can give. So just I'm going to create a group. External surface, add. So choose the surface model. So that is we can specify in convection or anything. So I'm just specifying it to convection. Just apply and close. This is enough to our model. We can create a body also. So volume group. This one is a egg. So now we are done of creating a geometry as well as creating the groups. Now we can save this file. Okay, just go to file, save as, pictures. I'm just navigating this into a folder. So study 2. Now I have saved it. Now we can move this into meshing model, mesh. So now we are in the mesh model. Select this sphere, go to mesh, create mesh. Go to NetGen 1D, 2D, 3D. I'm going to create a tetra element. NetGen 3D simple parameters. Here the value its default source 0.008, 0.001. I'm specifying it. Say OK, apply and close. Right click, compute. Any value we can specify it and we can generate it. So based on the user only, we need to specify which element size is enough to our case. So now we have specified the element size very small. That's why it's taking time to generate the mesh. So always it's better to specify the bigger value and generate the coarse mesh, then make it finer. That is always the better way of creating mesh. Instead of directly going for a finer mesh, around 85% is getting over. If it is very fine, we can reduce the element size also, because it takes times to solve. And now just see, we have generated a little finer mesh. We can make some little coarse. Okay, so this also we can take it, but it takes time. It will take some more time to solve. So for that, I'm just increasing the size. Just clear and compute. Yeah, this is enough, I hope. So now just have a look. So convection boundary condition, egg also came here. Now this is actually a linear mesh information. Just see, this is a linear element. So if you want to go for quadratic also, we can go. So if you go for quadratic, it takes more time. So for video purpose, I'm just taking a linear. Okay, just save it. Now we have done the meshing model. Just go for setup, aster study. So choose table always. So whatever the similar way previously we have created, same way we can go for. Simply we just a dummy setup will create. We'll save this file. result1.rmd, because the result file is already there, so I'm just naming as result1.rmd. Just save it, just finish it. Now I have created the dummy setup. From that we can modify it. First we need to read mesh. It's done. Model, it's a 3D thermic analysis. Okay, now material, we have a single material. Just go to here. So you have the material. The ordinary egg can be everything this, but the one thing is missing in this case. So I have taken this case from Sengel only. So one is row CP we have missed to take. Here they are specified as K by row CP, they have specified as this value. Now what we want to calculate is, from this value we need to get a row CP only. Okay, so they have given diffusivity, we need to get the value of row CP. So row CP is equal to this value. Just go to calculator. In calculator, now just see the thermal conductivity is 0.627. Here they have given, divided by this this value, will get rho CP, divided by 0.151 into 10 power minus 6. Just close the bracket, just enter it. So this is the value of rho CP. Just copy this value. I'm just keeping this into our case. So this is the value of rho CP. Density multiplication of specific heat, specific capacity. Now we'll use this value for density, because this is a transient analysis. We need to specify density and specific it, otherwise the solver will not solve. So now just go to the salome meca material, just edit this material, just double click the material, you'll get it. So this is, you can name it as egg mat for differentiate. Similarly, just go for thermal. I'm just searching here isotropic heat conduction material. Here the conductivity, just go to the case. The conductivity is 0.627. The conductivity is 0.627, and we can specify 0.627. 0.627 is the conductivity, and volumetric heat capacity, that is rho Cp. So rho Cp we have already calculated. Just copy this value and paste it there. Just save OK. Just apply it. Now see, lambda is nothing but a thermal conductivity, and rho Cp is nothing but density multiplication of Cp, specific heat. Now we have specified the material. This is assigning to the all, so just assign to all. Then load step we need to specify, that means boundary condition. Here there is no enforcement temperature. Exchange, just add it here. Group of element is the convection group. External surface, from the external surface only heat is getting transferred. Heat transfer coefficient and external temperature they have specified. Go to the case. So here they have specified the heat transfer coefficient is 1200 and the external temperature is 95. Heat transfer coefficient is 1200, external temperature is 95. Now just save OK. Just apply it. Now we have specified the convection. Now we are done. Then you just go for thermal linear. Thermal linear, in previous case also we have used a thermal linear solver for steady state analysis. Actually this case is a transient analysis. For that we need to generate time step. So for transient, so just go to this, save this file. We need to specify the time step with the defill list inst and defill list real. First go for defill list real. This is nothing but time period we need to specify. Start with 0, end with in seconds we need to specify 1200. So if you go for 1200 seconds, 1200 divided by 60, I'm taking just 20 minutes. I'm just going to calculate 20 minutes. So how much time it's taking to reach 70 minutes, we'll get it. So number of steps, in 1200 number of steps we can take 1. From that 1200 iteration it will do. Okay, just save OK, apply, save OK. Now we have specified this one. Similarly, what type of instant we need to do? We need to do with the auto method. So always better to use auto method. So time stepping is this one. Save OK. We have choose auto method. Just apply it. Save OK. Now we have specified the time period also. Now just go to the solver. Load step. Here we need to specify initial condition and time step. So go to initial condition. So initial condition value is 5. Initial temperature of the egg is 5 degrees Celsius. Now we can see here it is around it is a temperature of 5 degrees Celsius. Now just OK. And time stepping we need to choose this one. Simply just choose this list defi list, save OK, just apply it. Now just see here. So initial temperature is state initial is 5 and load we have specified. Increment is list inst. The same linear solver, it will become transient solver. if you specify initial temperature and time step increment. Solver is, so we need not to change anything in the solver. This is a mumps solver. There are different solver is there. So mumps is default solver, matrix solver. So just apply it, say OK. Now we have specified everything. Output also, this is enough. If you want to get it a heat flux, if you want to calculate heat flux also, just go for post processing, call champ, in thermic there is an option called flux elno and flux node. Just apply it, save OK. Now we have calculated, we need to rename it as the same name, temp. Just apply it, save OK. So the same name we need to give. Then just go here. Now we need to choose call champ. Here there is option called tau champ. You just make this into S, save OK. Just apply, save OK. Now we are done the setup. So just we will go through the setup again. We are reading the mesh, specifying the model, material we have specified. We need to assign the material to the model. Then we need to specify the time stepping. We are used auto time step and 0 to 1200 seconds, and pass is 1. Then load step, this is the load, convection load we have given. Then temperature solver we have specified. Then flux, if you want to calculate, we can go for flux calculation and saving the results. Now we can solve this case. So this is a transient, will give some more memory. 4 GB I am giving, just instead of 15 minutes, just 50. So 50 minutes I am giving. Just run this case. Just saved it, just run it. If any error comes, it will show in the message file. So in this problem, in analytical value it shows 14.4 minutes. That means 14.4 into 60, around 864 seconds. It reaches the core of 70 degrees Celsius. The core reaches 70 degrees Celsius at the time second of 864 seconds. Now we'll check in finite element analysis. Now it is getting solving. See, it is solving very quickly. Now it is solved 1200 seconds. Now it's saving the results. So this is the file it is generating. Now we'll see where it is saving actually. Just go here. So this is our case folder. I'm named as study2. Just go to the study2 folder. There is a folder called run case 1. Here result stage 1. Here only it's saving actually. So this is the mesh file, MAD format. This is script, and this is the command file. So whatever the value, whatever the command we are specifying is, that's the same command will generate here. So this only is the uses the solver to solve it. I will close this file. Now we will go to salome. Just see, this is solved and saving the results, copying the results. Now just go to the folder here. The result file is little bigger, it seems. That's why it's taking time to save the results. Yes, now results are available. Now it is saved the results without any error. So see, a diagnostic job is okay, and you can see the iterations also how it is getting solved. So every iteration it is solved and saved the results. Now we can go for post processor. That means we can go for paraview to view the results. Go to paraviews. Just build in, open. Navigate the file. I have saved as result1.rmd. Just save OK. The file is little big, that's why it's taking time. Just apply it. So this is our egg temperature. So at the time 0, the temperature is 0. Similarly, we can check. We just simulate this one, because it has to read every time step to read the results. Just wait for a while. It has to read completely. Then only the scale will get update. It's running around half of the value it runs. It has to go to 1200. Yes, now it is done. Now again we just go here. Now see, the plot is getting updated. So once it is done, it will get updated. Now go to temperature. Now we can slice this sphere. Will be how that heat is transferred inside the sphere. Just go for clip. Just hide this one, apply it. So we have taken just 1/2 of the egg. Now we'll simulate this value. Now see, from temperature, from the heat is transferred from external surface to inside core. That is a way the egg is getting boiling. So initially it is around initially it is in temperature of 5 degrees Celsius. We are putting this egg into a 95 degrees Celsius temperature and with a heat transfer coefficient of 1200. So now from the outside surface the heat is getting transferred. So from the analytical value we are getting the results of around see here 14.4 minute, around 865 seconds it reaches the temperature of 70 degrees Celsius. So we'll check here when it is reaches around 70 degrees Celsius. Yes, just update. $865. Now we'll check the temperature here. Just go to over point. See here temperature is around 70.8187. So the core is getting reached 70 degrees Celsius in this point, around 865. If you increase the time, for example I'm going for 918, the temperature is 73. It's more getting heating. So around 1200 for 20 minutes it reaches a temperature of 81 degrees Celsius. Now we'll plot this temperature, how it is getting heating. Okay, so just go to filter, search, there is an option called plot. Now we need to choose plot data over time. Just enter it. Now select the midpoint. Instead of over point, just go for a selection option. Select the point. So I selected this point, just apply it. Yes, now it is generated. First we need to check how it is data is getting generated. First the x-axis, x array is the time and y array is to be a temperature. So now x array is the time and y array you just untick all, only you just choose temperature. There is option temperature, so this one is a temperature. Here there is average value are showing because I have selected 2 or 3 nodes. So this is the way the heating is happen. So the center core is getting heated up like this. So around 200, the temperature is 48.8. For 300, in the time of 300 it's reaching the temperature of 62.48. Like that the temperature is, the inner core is getting heated up. So now we can change this color pattern also. Now we can simulate. Now this way heat is getting propagating. The temperature around 865 seconds it reaches 70 degrees Celsius. The inner core is reaches 70 degrees Celsius. Thank you for watching my videos. In that we have finished this tutorial of transient heat transfer analysis of boiling egg. Thank you for watching my videos. Please subscribe my channel for more videos regarding code aster, ANSYS, CFD, computational fluid dynamics also. So thank you.